Hello again, welcome to day 11 of Advent of Code, and today we'll be solving cosmic expansion. So in this problem we are given a map of galaxies, and our goal is to calculate the shortest path between every pair of those galaxies. And then there is a catch where when we encounter a line or either a vertical horizontal line or vertical column of only dots, those areas are expanded. So any rows and columns that contain no galaxies should actually be twice as big. So it means that this line, and this line, and this line, and so on are actually twice as big, twice the size that they are in the input. So it actually looks like this. So the distances are then greater than it originally looked like. So to calculate the distance is quite easy because you have the positions. This is the 2D grid. So the distance is essentially the difference between the X positions and Y positions. So that's super easy. The tricky part is to expand it correctly. So let me take the input, the simple one, and now let's calculate the solution. So I'll read the input from the input file, and I will store a map of characters, and this map will contain the individual things. So do XY, just read it out into the input map. And what we will do is now to find empty columns. There's going to be a list of int. And empty rows. So those will be two lists of empty rows and columns that we encounter. Now, how do we get that from the information? So I will go for each column first. So the number of columns is width, length. So this is width is okay, like this. This is the input length, and height is this. So height, width. So for each column, we'll check if it's empty. So var is empty, true. For row to height, we check if that character is not dot, which is actually correct, then we mark it as not empty. So if it's empty, then we add empty columns, and we do the same thing for empty rows. And compile is very useful here. So it actually wrote exactly what I wanted. So it checks for column, a row, not empty, and then adds that to the empty rows. So that's good. So we have the most important part of it already resolved. So now for each of the galaxies, we need to calculate the shortest distance. Okay, so for each of the distances, we calculate the shortest path. So okay, maybe what we can do is var galaxies. It's gonna be a new list of point, so all the galaxy positions. So if map xy equals hashtag, then we add galaxies at point x, y. So we store the positions so that it's then easier to calculate. So for each galaxies, so for each of them, we will calculate the distance. For each galaxy, so we will have a long total distance. So, and now when we take for each other galaxies, so if it's the same, then we skip it because it's the same one. And now the distance will be exactly this. So the difference between x's and y's. But we also need to add for each of the rows that are empty in between them, we need to add those twice. So empty rows and columns between those galaxies. So so empty rows will be empty rows count of those which are where a row is math min galaxy y other galaxy y. So if where the row is greater than if where is greater than minimum of those and also lower than math max. Galaxy y. So this should give us the number between and empty columns between columns. It's gonna be column x column okay. So this should give us the number of those, and we need to increase the distance by empty rows and empty columns, because all of those are counted twice because they are twice as big as they are supposed to be. So this should be it. And now total distance, also right line total distance. So we have the distance and we add it to total distance. So if I didn't make any major mistake, it should be enough to solve this. Although I see that somehow I counted it twice, because I counted the distances for each galaxy from both directions. So so because I'm going for each, not just for to the others. So I could just make it simpler by doing 4 and start with the others and not go to the previous ones, but it should not matter in this performance wise. So this is the correct solution. So now let's try with the big input. Okay, quite a big number, but it could be fine. And it is. All right, so we have the first part solved, and now onwards to the other one. So now instead of the expansion we did before, each empty row or column is 1 million times larger. That is, each empty row should be replaced with 1 million empty rows and so on. So the difference here is that instead of adding the empty rows as they are, we'll be adding them with a multiple. So this should be quite simple. So I'll put it here for a simple input. And now instead of this, we should add them up 999,999 times. That's because they should be a million times larger, but we already counted them once in the absolute difference. So now it should be this, if I'm not mistaken. So let's see. So this is the solution that we got. Oh yeah, so this is just smaller because they have 100 times larger. So let's see what it does with the big input. Maybe it will overflow. No, it seems to be okay. So let's see if this solution is correct. And it is. All right, so we have solved day 11 quite easily this time, much easier than day 10 for sure. So yeah, this was quite successful. And we are ready for the other days. So I will be back for another videos, of course, but taking it one step at a time. And I will also make a video for day 11 or for ChatGPT to solve this problem as well. We'll see if it takes this simple approach of counting the rows and counting the ones that should be counted multiple times, or it will be trying to expand the map, which would be inefficient and especially not working for the million size increase. So we'll see. I will make that video and I will publish it soon, so stay tuned for that, and I will see you in the next one. So bye bye.